Okay, so when they asked me to come and speak about what I do, I thought about talking about the role of data in running a hardware startup, but then I thought, oh, actually it's more useful for me to tell everyone all the things that I wish I knew before I started this company. So I'm CEO of Other Machine Company, and the things that I wish I knew really affect these people. So we all set out on this quest together, and there's roughly 22 of us now, and we kind of set out on this quest without knowing very much about what we were doing, and I think it would be helpful if more people who want to form companies or establish products in the marketplace actually knew before they jumped off the cliff with a bunch of people what they were getting themselves into. So, the 4 big things I wish that I knew before starting this hardware company were to be very specific about the market. We built a thing that we loved, but we weren't really sure who it was for. We didn't know how big that market was, and I wish that I had known that the way you decide to manufacture a piece of hardware mostly depends on the quantity of those things you want to make 3 years from now. And also that the good habits that you set up with data early on can help you scale using less people. So caveats, this is just my experience. I'm actually a materials scientist. I have some good advisors, but no formal business training. I'm running a 22-person venture-backed startup. We sell a $2,200 product. We do final assembly in-house, mostly with components that we get made around the Bay Area, actually. So everything you hear from me, follow at your own risk. So this is what we make. It's a portable, high-precision desktop machine, which allows you to cut 3D objects out of durable materials like wood and metal. So we built this tool, and we didn't really know who it was for. So we have a product. Who's it for? So the first 3 things you need to do are describe the buyer. So the buyer is not always the person who is using the machine. Sometimes it's different. The other one is identify the friction that the user of your machine or your object or whatever it is, your headphones, is currently experiencing, and then identify the value that the product provides. This seems really trivial, except for it's super important because it determines how big is your market and how you reach people and things like that. So let's take, for example, the product's called the Other Mill. That's what the product that we make. So it's a product that mills printed circuit boards, and it's priced at $2,000. So it does a lot more than that, but let's just take that as an example. First thing you should know is don't try to sell it for less than 3 times what it costs you to make it. That's the first thing I wish I had known. So who's the buyer? And you really need to be as specific as possible here so you can go after the right number of people, because in the beginning you don't have enough resources to go after everyone who wants to make anything. You have to say like very specifically who you're going to go after, and that helps you reach them and find them out in the world. So the buyer for a product like this: electrical engineering faculty, post-secondary, United States, educational institution with at least 25 students in the program, 1 lab course that is in their program. This is super specific, but it helps you define the product and figure out how to reach people. So the current friction that this buyer is experiencing is actually their students. So they want their students to go on and get good jobs and things like that. So right now their current friction is they're maybe not making circuit boards, or they're using chemical etching, which is not something that they're going to be doing at their job later, or they are using an external board fab. An external board fab is great for people who are experienced, but these students make a lot of mistakes. And if they have to wait 1 to 3 days, pay $50 to get their boards over and over and over, that's really slowing down their development process, and that's what the buyer, the professor, wants to get rid of. So the value proposition: students will iterate quickly, get more hands-on experience at low cost, and get better jobs. This is the basis for everything that you do from that point forward. What does the software look like? What does the packaging look like? How do you advertise this piece of equipment? Things like that. Unless you have this, you're just going to waste money and time, which is especially key if you don't have a lot of those. So say we sold this to people who are doing PCBs. This is the stuff that they make, and that makes us feel really good. But is this market big enough to build a company on? This is another thing I wish I had known how to do. And it's very straightforward. So you look at how many possible people would buy your product and then make some assumptions. So there's 7,000 post-secondary institutions, 30% of them have electrical engineering departments. Basically, we know from using the tool that 5 students can use the machine, costs $2,000. Each school has 25 students in it. So you just do the math and it's $20 million. So whether or not $20 million is a big enough market really depends not on what investors say or anyone else. It really depends on you and what company you want to build, and how much it will cost to run your company in the first 2 years, and how much money you will earn in the first 3 years, because you're not going to earn any money in the first year, most likely. So you can do a lot with these numbers, but the point of a ballpark is that you need a starting point. You need to overestimate what your needs for running the business are, and then you can know how much money to raise, or if you want to raise it all, know how many people you can afford. So I've done a lot of research. A person costs $150K per year to you, overhead, everything included. And that's if you are hiring people who are engineers and people who are, salespeople and different people, it kind of all averages out once you get, around 10-ish people. And in the beginning, you're going to have a lot of R&D costs. So it's roughly 25% of what your overall expenses will be. So if you have 10 people, 2 years, and $150K per year, that's $3 million. 25% of your total expenses will be $1 million, so you really need about $2 million per year, coincidentally. $4 million total for your first 2 years, because you won't be at break even by that point. But $4 million is really how much money you would need to raise in order to run a company of 10 people that has heavy R&D expense. So one of the things that's great about investing in software is that you don't have most of this. You have a couple people, there's no overhead, you can get to product really quickly, get it out there, there's no distribution costs or anything like that. And that's why hardware is so much more risky for software, or risky than software. And that's why cash neutrality is so much more important for hardware than it is for software, because you need to de-risk things like production and your sales process and your customer experience and support and all those things. But it's really possible to do, you just have to be a little bit more conservative. So really the metric is you need to earn 3 years of operating expenses in your first 2 years of sales, but you don't get to make anything the first year. So and also you're going to make about 0%, 20%, and 80% of your money in years 1, 2, 3. This really works out to be, and all this is really based upon your team size, which we'll get to later. But so if you're burning $2 million a year on average, year 1 maybe you don't hire as many people, year 3 you hire more people, but you're going to be earning about this much money. So at the end of the year 3, you need to be sort of break even from what you spent initially. The reason for this is that, you see you're actually earning way more in year 3, but then you still need to keep developing. And so you need to put cash back into that process. So how much could you get from a $20 million market? So if you know that you're going to need $6 million total over these first 3 years, how much can you really get from the $20 million market? So you can expect only about 5% market penetration. So maybe you will know something more about your market, or you'll produce something that is really, really catchy for people and they'll fall in love with it, but most don't. And so you need to make sure that you're not setting yourself up for failure. So your market needs to be about 20x what your revenue needs are. So if you need, whoops, that's not a pointer. If you need 6 million, you need a $120 million market, and 20 million isn't enough. So a lot of people find themselves at this position and they just ignore the facts. They just go for it, and they're like, whatever, we won't pay anybody anything, and we'll just go for it. This is going to be way bigger, but that's going to make a lot of people sad sometimes. I don't know if you keep up with all the hardware companies. Well, I'm kind of morbid in some ways, so I watch all the hardware companies fail, and I'm like, every time. So anyway, so your options are, at that point in time, you're like, okay, well, we could add more markets. So we could reach out not only to electrical engineers, but maybe we could do mechanical engineers and things like that. The only danger with that is that you are diluting your product's message. And in the beginning, you only have, so many dollars per people that you can make contact with. And so you need to be very concentrated about how you reach them. So the option 2, get by with less people, bootstrap, that's what most people do. Or 3, build a different product, but that's, that's sad. You don't want to build a different product because you really love the first thing that you build. So bootstrap it. This is the fun one, and I think a lot of people should do this, and Kickstarter plays a role in this as well. So you can actually, conceivably, you have a person, and you spend 100K on R&D, because that's, the 25%. You're going to spend a little bit more because it's just you doing all of the work. But actually, you could get, with only 5% market penetration in a $20 million market, you could become profitable and actually hire someone in year 3, which I would take as like your reward for investing 500K, which is when you add up years 1 and 2, 500K in wherever you got it from, angel money, nest egg, maybe you worked at a corporate job and decided to give that up, and you spent your own money or whatever. This is what most people actually do. They just don't rationalize the amount of money or the kind of opportunity cost they're spending on their own company. But this is actually really great, and there's a lot of products out there that are perfect for $20 million markets or $50 million markets. And I kind of say this whole story because it's kind of an antidote to like the VC funded everything, is that it's really great to have small businesses that make $1 million a year. I would love that, but not everybody, that doesn't get a lot of press because it's not exciting. Like, you and a buddy started a $8 million a year company. That's amazing for your families, but not the story VCs want to hear you say. No offense, FirstMark. So then you get to this point, which is you decide to jump in, and you're either going to take outside investment or you're going to bootstrap it, and you need to make parts. Of course, there's trade-offs, flexibility. So the number one thing that I list about flexibility in the way you manufacture your product is because the less experience you have, the more flexible you need to stay, because you're gonna make a lot more mistakes. And you need to minimize the cost of making those mistakes. So things like investing in $100,000 to make one injection mold, if you look back, you're like, okay, well, that's my whole 100K year 1 R&D budget. I can't really do that, so I'm gonna have to figure out something else. The other thing is speed. How long can you wait to get out into the market? Maybe it's not so urgent, but maybe it is. Cost. As long as you're optimizing cost and you're at least trying to sell a product for 3 times what it costs you to make it, don't bother optimizing beyond that. You'll figure it out later. Quality. You're always going to compromise on quality, and it's not really whether or not you're building the best possible quality product, but it's whether or not you can deal with the fallout of choosing low quality processes or parts. And maybe you need to invest later, but you can kind of make the investment in fixing the quality decisions 2 years from now when you actually have more infrastructure. So even with all of those things, I found that most people fall into one of these categories and it works pretty well. So of course, you need to ask how many objects do you need in year 3? And this depends a lot on the price point, but more so it depends upon the quantity. So if you're making 0 to 1,000 units in year 3, just make them in-house, because you really need to build the first 1,000 of anything yourself to understand quality, to understand how it's manufactured, to know how you're gonna develop V2 whenever you get to that point. 1 to 5K in year 3, that's really us. That's like what other machine company does. It's a hybrid. So we do final assembly in-house because we need to keep an eye on that, but we use local manufacturing. So within a day's drive mostly to make all of our components. 5 to 10K I see is like local outsource. So no ocean plane rides to get it made. You're not making it all, you're not doing final assembly in-house anymore. You have a facility that's your partner nearby. The reason I say no ocean plane rides is because if you add up all the costs, it's usually about 20K per month to have someone in China, whether it's someone on your team or an outsourced firm that you pay to manage that relationship. 20K a month and you're only making 10K widgets, that adds $24 to the cost of each widget. Now, depending on what your widget is, ours is $2,000, and there's no way I would go through that hassle because you also sacrifice speed and things like that. I still don't think it's really appropriate. Above 10K is large volume manufacturing. That could be nearby, could be abroad. Really at that volume, you're engaging someone who's tier 1, like contract manufacturers. And in my opinion, if you're gonna go through the effort of teaching someone else how to make it, teach someone who's really good at making it. So just go for the best. This is our line. This is a batch of 12. It's in an old pipe organ factory. So we get all of our components made elsewhere and bring it here and assemble them. It's very simple. We just have bins and labels and systems for keeping track of things. And it's actually totally profitable for us. But it's profitable because we did one thing early that was really valuable. We started taking great data. So production data. How many can we build? How long does it take? How much does it cost? When do we need to place orders? All that should be computer. There shouldn't be a single person who has anything to do with that process. Also the product history. What are the parts that are in machine, 1, 2, 3, that machine? Where did they come from? Who assembled it? How long did it take? The reason you do that is because you're gonna put a product out in the field way before you have time to do extensive product testing. And if you don't have time to do extensive product testing, the only thing you can do is be able to solve problems as quickly as you see them and spot trends within your data. So if you see this machine, you're like, uh-oh, there's 2 of these machines that have a bad bearing. Okay, let's track all these machines that have a bad bearing and just proactively ship out replacement bearings to all the customers that had machines in that batch. Things like that are the way you can do more with less people. And the other thing is support tracking. So tracking the information that will inform your engineering teams about what changes to make, if your customers have feedback and things like that. It's also a way to know how to scale support. So people will forgive you for making all kinds of egregious errors as long as you help them out. And so knowing what your support volume is and proactively adding people to that task is really helpful. So the last thing I wanted to show you is just what it looks like under the hood. So when I say production data, we built just a web app. We hired, general web developer to show us visually all of the 227 parts for the other mill, the machine we make, and the sub-assemblies that it is in. And this is all passive. So a box comes in the door that's like whatever, screws, and you enter in how many screws you have, and all of that populates how many you can make of each thing, how long it's going to take. This is a fun one too. So at any point in time, given the stock that you have online, this is accessory kit bagged, all the things that are in it, how many we have on stock, how many we project to have on stock with current supply, things like that. And then this is the really great part. When people interact with this system, it's very simple. I assembled quantity of part whatever it is. I scrapped whatever of part whatever because something. I shipped this. When do you order things? This is the best way to make efficient use. So we can build, maybe, I think it's 100 a month with 3 people. And that's because, and it's a high precision, very complicated 227 part machine, but it's because we have a web app that tracks all this data, and we've been tracking it historically over the past 12 months. So we know exactly when to do what. So I guess, in summary, I hope you learned something from all of the things that I shared, and maybe you'll make fewer mistakes than I will. And I'm happy to answer any questions.
So much. This was awesome, and really appreciate you being so generous and sharing all this with the community here, as opposed to just talking about your product. But since you've done that, actually, let me give you an opportunity to do that and tell us more about the product, where you are as a company, what's coming next.
Yeah, we're just trying to build as many of these things and get them out the door as soon as possible. We sell this thing that you can carry around, and you can make finished goods with it out of metal or wood or circuit boards. The idea, and you can interact with it just by giving it files you already have, like 2D vector drawings. It'll cut that. You can give it circuit board files if you're into that. You can just feed it those files, and the software is super easy to use. And the idea is that like nobody's going to incorporate machines like this into their businesses or their lives unless it's, you know, basically you don't have to go through training to use it. And so that's kind of the mantra that we've used to bring a machine that's kind of complicated to people who don't have engineering educations.
How long did it take you to build out your own web app for inventory? I mean, I imagine it's probably somewhat iterative, but how long from conception to it sort of being useful to you?
We had been tracking a lot of things just in spreadsheets, so it was more about converting those. Converting all of our kludged together spreadsheets took about 2 months to get something that had a web interface that someone could interact with without manually changing the spreadsheet in the background. And there's a lot of like off-the-shelf things you could get too. For us, we just wanted to make it super clean.
You said you didn't really talk a lot about the product, but I was curious of its advantages over Squink or Volterra or Argentum.
Oh, the circuit board printers? Yeah.
As far as circuits go.
As far as circuits go, we're kind of more towards the pro end. So you're building a thing that you actually need to prototype and take to FCC testing, for example. So you really want your circuit board to have the kind of material properties and impedance and everything of your final board, and that's really hard to achieve with like ink being printed and things like that. So it's more about, you know, you can prove things out and do chip selection and things like that, but when it comes to actually getting something that's going to be sturdy, you can give it off to your firmware team, you can hand it to the people who are doing certification, things like that. You really need to have a physical, rigid board with cut copper and things like that.
Running.
Hi, thanks a lot for your presentation. I see you're doing a hardware, sounds really exciting and interesting, and you have a very specific market that you discussed. But clearly you want to access also a very wide market. So how do you do that through your application? How do you speak to the nerds or the geeks or the engineering students, but also speak to the moms or the kids that might want to try to make their own stuff at home? How do you make that kind of maybe compromise, but also best solution?
Well, what's great about a product that's pretty general, like this is a milling machine, it could kind of make anything, is that you just choose at what point in time you want to start talking about it and you want to produce the content or the software features that really support that market. Right now you can import a circuit board file, but that doesn't really help someone who's making jewelry in the conventional way, things like that. So over time you tailor an experience to a specific group of people, and you're going to hit a lot of people on the fringe, but you just start showing people in your marketing materials that are in that demographic and showing them making things that are the type of things that those people would like to make. But it's really important. We actually, the first website that we ever made, we had a bunch of like jewelers and stuff like that on it, and we're like, oh wow, no, we just sold for 3 months and we had one jeweler out of a ton of people. And we're like, all right, this is the wrong message for the people who are really resonating with the product as it is right now. And so we're like, all right, circuits, they love it, it makes their lives easier, let's go for that first, and then really adapt the product with content and software over time to help out more groups of people.
Have you been able to print in pipe yet?
No. Those are cylindrical and conical. I mean, I do want a fourth axis on the machine. That would be great. And then we could do things like an actual pipe organ pipe.
So it's not related to hardware, but so when you conceived the product idea, how did you validate the product? How did you validate the idea? How did you know that electrical engineering students in the US actually want this?
It was built by someone who really wanted to make guitar effects pedals, and then we ran a Kickstarter campaign with a very narrow message, which was just custom circuits on your desktop. And then we got a lot of feedback from, I mean, we sold like 200 machines to people who wanted to do circuits, and we're like, okay, well, that's something. That was kind of it was nothing more complicated than that.
All right, thank you so much.